Okay, on to page 3. So an airplane flying due east at 515 miles per hour in still air encounters 34-mile-per-hour tailwind, acting in the direction 30 degrees north of east. The airplane holds its compass heading, but because of the wind acquires a new ground speed and direction. What is the new speed? And I'm just going to throw in direction because who knows, maybe on the test I want both. So in any case, so if I just make a kind of a quick sketch of these vectors, what's going on here. So first of all, we have the airplane flying due east. So this will be east. It's flying due east. It has a magnitude of 515 miles per hour. That means this vector component is 515 comma 0. So that's the component of that vector. And then we have the tailwind, which is 30, which is acting in the so 30 degrees north of east. So that's north from east. So that's 30 degrees. And it has a 34 mile per hour magnitude. And because it's 30 degrees, if you think about what's going on here, so in this triangle right here, this would be the shortest side, which would have to be half of that. So this has to be 17. This has to be 17 square root of 3 right there. So this component vector would be 17 square root of 3 and 17. I don't know why I put way too many commas there. So yeah, there you go. Okay, so those are the two component vectors that we have. Okay, so the new vector that will be given, it will be the sum of these two vectors. So the new vector component is going to be equal to 17 square root of 3 plus 515, and then 17. Okay, so with that being said, if we want to find, so that, whatever that is right there, so whichever, I'm going to assume it's somewhere in between, but in any case, so this new direction and speed is what we're looking for. Speed is going to be the magnitude, and magnitude, which would be denoted like this, would be equal to the square root of x squared plus y squared. So 17 square root of 3 plus 515 squared plus 17 squared. So that's going to be your magnitude, which is going to be the new speed, essentially. That's going to be your new speed. So go ahead, give that. That's going to be in miles per hour. So you can go ahead and throw that into a calculator and get the answer there. The new direction. So the new direction is going to be this angle right here. So with that being said, it's going to have a x and a y coordinate, right? So x and a y distance. And to find the angle of that, the angle will be equal to tangent inverse, so arctangent of opposite over adjacent. So remember that your y value here, so this is going to be equal to your arctangent of 17 divided by 17 square root of 3 plus 515. So that's going to be your new angle right there. So your new direction. So in degrees. So make sure you're right. Yeah, you're probably going to want to make sure that your calculator's in degrees. So all right, there you go. Again, I would recommend that you just if you want more practice, there's the one that we did in the homework. If you want to redo the homework problem that we did, there might be another one. If you look in the exercises that happen before the homework, so the ones that we do like in class, you can also look at that in the book. So there are some more examples in the book if you want more practice with this. A particle travels in the plane with position vector r of t. So when it says that the particle is moving in the plane, just note that with a position vector, it's probably going to be defined parametrically. So here's your x and here's your y. So it's moving in the plane, and that's how you can find its position. So there's the position vector. So find the acceleration vector a of t, which it's pretty easy. So the velocity vector is just going to be your first derivative of your position vector for x and y. So this should be 2t plus 2 sine of 2t, I believe, because the derivative of negative cosine is positive sine times by the derivative of the inside. So there's that, and then comma for your y prime dy dt. That's going to be 2t minus 3 cosine of 3t. So yeah, I think that's good. And then your acceleration vector is just going to be the second derivative of your position, or the first derivative of velocity. So that's going to be 2 plus 4 sine of 2t, and then that's going to be 2 plus 9 sine of 3t. And then if it were asking you at a specific time, you just have to plug in t. If it's asking you to find speed, note that speed is going to be the magnitude of your velocity vector. So make sure you watch out for that. Yeah. Alright, so a particle moves in the plane with the given position vector. Find the velocity or acceleration vector as indicated in the specified time. So so find the velocity vector at t over 3. Give your alright, so velocity. Let's find velocity vector first. So v of t is going to be equal to the derivative of the inside. First of all, is going to be times by 2. So I think this is going to be negative 6 sine of 2t, and then this is going to be 6 cosine of 2t, and then the velocity vector at t equals pi thirds is going to be equal to negative 6. You'll have sine of 2 pi thirds, and then you're going to have 6 cosine of 2 pi thirds. Okay. And then, yeah, cosine of 2 pi thirds. So, trying to think, 2 pi thirds. So, if you do a quick sketch of that. So, pi thirds, 2 pi thirds, 3 pi thirds. So, 2 pi thirds would probably be like that. So this is pi thirds, which is 60 degrees. So this is going to be negative 1. This is going to be 2. That's going to be square root of 3. So sine, so it's going to be equal to negative 6 times by square root of 3 over 2. And then this is going to be 6. And cosine is going to be negative 1/2. So it's going to be equal to negative 3 square root of 3. And then that's going to be equal to negative 3. So there's your velocity vector right there at t equals pi thirds. That's kind of weird. It's asking you to round. Pi thirds, in this case 2 pi thirds, is a special angle triangle. So if you're given a special angle triangle, I expect you to give exact answers. So in any case, if r of t is the position vector of a particle in the plane at time t, find the particle's speed. Okay, so this is what I was talking about earlier. So if you're trying to find speed, so we're given the position vector, so the velocity vector is going to be equal to, so that's going to be negative 6t, derivative of 2, 0. So, and then it's going to be t squared. So, and then v of 1 is going to be equal to you're going to have to plug in 1 into your velocity vector, so it's going to be -6, and then just 1. But to find your speed is going to be equal to, you'll have to do the square root of -6 squared plus 1 squared, which is going to be equal to square root of 36 plus 1, which is going to be equal to square root of 37. So that's going to be your speed. What units are we using? I guess no units are being used, so units per second, units per minute, whatever that might be. Okay. All right. Let's see. So velocity, the velocity of a particle moving in a plane is given along with the position at t equals 0, t equals 1. Find the position. So let's see. So we're going to want to use an integral then. Yeah. So r of t is going to be equal to the integral. So, well, first of all, it's going to be, you're going to have to use the, you're going to have to find the integral from 0 to 6 of the x part. So that's going to be 15t squared minus 4t. And then with respect to t, and then the y part, which is going to be integral from 0 to 6 of 1 plus cosine pi t dt. All right, so yeah, r of t is going to be equal to, so let's do the antiderivative. So the antiderivative of that's going to be, that has to be t to the third, so that's going to be 5t to the third. Minus, that's got to be t squared, so that's going to be 2t, and that's going to be from 0 to 6. And then that's going to have to be t, and that's going to have to be plus sine of pi t divided by the derivative of the inside, because it's antiderivative, so that's going to be pi from 0 to 6. Let me just double check that. So if I were to take the derivative of this, derivative of sine is cosine, you'd have to multiply it by the derivative of the inside, which would be pi, but we have a pi here, so that would cancel. So yeah, I think that's right. All right, and then so r of t is going to be equal to, if we plug those in, 0, 6. So if we plug in 6, that's going to be huge. So let's go ahead. Sorry, I have my calculator here. So you're going to want to plug in 6 here. So 6 cubed times by 5. So 6 to the third times by 5. That's going to be 1080. Minus, then you're going to plug in 6 there. So 36 times by 2 is going to be 72. So minus 72. And then you're going to have 6 plus sine of 6 pi. Well, sine of intervals of pi, that's going to be 0. And then if you plug in your lower bounds in any of these, so if you plug in 0 and you plug in 0, everything's going to be 0. So don't need to worry about that. So that's going to be equal to, so 1080 subtract, that's just going to be 100. That's 10,008. And then that's going to be 6. Okay, so that was your displacement. So it does say it wants your what does it say? So the velocity vt, a particle moving a plane, is given along with the position. So its initial position at t equals 0 is given here. Find the position of the particle at t sub 1. So t equals 6. So that's why we integrated from 0 to 6. So that was that part. We integrated from 0 to 6. So that was for the first 6 seconds that the particle was moving. And so the new position, so the position is going to be equal to, well, the initial position at the x was 6. So 6 plus 1008. And then 6 plus 6, which is the position of y. So the new position is going to be 1,000 and 14, and then 12. Okay, so I think that's it right there. So this is new position. Don't forget to add on the initial position. So remember that the integral from 0 to 6 of your x and your y over a given time interval is the displacement. So not the position. Don't get that mixed up. It's displacement. So we moved this much, but we were at 6. So that's how much we moved in the x. We were at 6 in the y, but we moved 6, so we're going to be at 12 right there. So that's the new position. Okay, the velocity of a particle moving in the plane is given by that vector. Find the distance traveled. So distance traveled does not care about initial position. So in this case right here, so we're just going to want to do the integral from 0 to 4 of the square root of this is going to be x of t squared plus y of t squared. So it's I believe it's just the same. It's just the same formula for the parametric curve, the length of a parametric curve. So we already did a problem like this up here. So the length of a curve, it's just the same problem. Sorry, 1 second. However, so this x of t is already the velocity. So if I were given a position, I would have to find the derivative. But this x and y of t are from the velocity vector. So we don't have to worry about taking the derivative. We could just use that right there. So this is the integral from 0 to 4 of the square root of, so x of t is t plus 3 to the negative 1. And if you square that, that's just going to be t plus 3 to the negative 2. And then plus, and then this part right here, y of t squared. So you're going to square that. So that's going to be t plus 4 to the negative 4. Now looking at this one, I definitely do not think this is one that you're gonna do by hand. That's definitely not one that I would try to do by hand. So I would just put that into a calculator. Watch out for negative exponents that you put those in right. Don't forget about your radical as well. All right, a baseball leaves a bat at an angle of 60 degrees from the horizontal, traveling 87 feet per second. Find the position vector and the of the baseball at time t. So just kind of a visual. This is not quite like the airplane one, because in the airplane one both vectors were constant vectors, not variable. They weren't vectors with variables, which in this case you're looking to do that because the vectors are not constant. So that means that you have a parameterized curve pretty much. So here is the trajectory of the baseball, I guess you can say. And initially, the initial vector, you could say, so it's going to be hit in the direction 60 degrees, and the magnitude is going to be 87 feet per second. Okay, so if you were to make your component vector, and now it is a vector function, not a constant. So for the x variable, remember that if you're going to make a vector, the x value is your magnitude multiplied by cosine of theta t. And so in the case of the airplane, you don't need the variable. So if you're just using constants, you don't need the variable. And then this one's going to be the magnitude times by sine of theta times by t. So that's what it's going to consist of. But we also have to consider gravity in this problem, so we're going to have to use the gravity vector. So in any case, so this one should be, the magnitude is 87, and then you'll have cosine of 60, and then that's going to be t. So that's not, so this is a constant, and then t is the variable. So t is not a part of what's inside cosine, and then you'll have 87 cosine of sine of 60, that is sine of 60 times by t, but we're going to have to subtract 16 t squared for gravity. And then, well, cosine of 60, so if you have your 60-degree triangle, so that means this is 1, this is 2, this is square root of 3. So cosine is going to be 1/2. So your vector is going to be 87 divided by 2 t. And then sine is square root of 3 divided by 2. So 87 square root of 3 divided by 2 t minus 16 t squared. So here is your position vector. So this gives you the position of the vector at any time. So r of t. Now, I would review your homework problem. We did have a homework problem with the baseball, with an example of a baseball. I would review that because I'm likely to give questions like that. So at my questions on the test might ask, when does it clear the fence? If it does clear the fence, will it clear the fence? If the fence is this many feet out, so it might give you like the fence is, 250 feet out. So you can always set that equal to your x distance. So the fence, you would have to relate to the x, okay, and then this would be the height. So if you want to find the height at so many feet, then you would have to find t first. So you'd have to find that from this part. But again, refer to the example in your homework, because I'm likely to I'm likely to give a question that's based off of one of those rather than just stating something like this right here. I might ask you to find the speed whenever it hits a fence out there, etc., etc. So just be aware of how you can solve those. All right, so coordinates. So change the given polar coordinates to rectangular. Okay, so here's a polar coordinate. So this polar coordinate has an angle of negative pi thirds. So negative pi thirds would be right here. But it also has a negative r value. So that means you're going to want to put it in this direction right here. So this would be negative 4. This right here is negative pi thirds. And so that means right here, this would be this would be 60 degrees. And this right here, if it's 60 degrees, that's negative 4. This would be negative 2. This would be negative 2 square root of 3. And so that would mean the rectangular coordinate would be negative 2, that should be positive, 2 square root of 3. There's a rectangular coordinate there. Yeah, just watch out if r is negative, you go in the other direction that it's pointing. Okay, so rectangular coordinates. The rectangular coordinates of a point are given. Express the point in polar coordinates. So, so we have a rectangular coordinate of 0, negative 2. So one way that you could express that as a polar coordinate, so you could say 2 as the radius, and then you could say 3 pi halves. You could also say 2 and negative pi halves. You could say that. You could say negative 2 and pi halves. You could say negative 2 and negative 3 pi halves. So multiple different ways that you could write that polar coordinate. But it does say that theta is between 0 and pi half, so that would eliminate that right there. Those two. Find two sets of polar coordinates for the point. So essentially just the same thing. It does say r is going to be positive though, and theta is between 0 and 4 pi. So in case, I think you can find that. Okay, so for the given polar equations, write the equivalent rectangular equation. So if you guys remember, we did have so equations that helped us. So r cosine of theta is equal to x, r sine of theta is equal to y. So we had equations like that. We also said that tangent of theta is equal to y divided by x, and we said x squared plus y squared is equal to r squared. So here are some equations that help you convert from polar to rectangular. So in this case, so r cosine theta, r sine of theta. So this right here is x. This right here is y. So we have 4x plus 5y is equal to 1. You can easily simplify that and solve for y there, and but I think that's fine too right there. For this one right here, this one is a little bit more difficult. We did something like this on the homework and in class. So, excuse me. I think it requires a complete the square method. So if you see something like this, r is equal to 4 sine of theta, well, something that you could do is multiply both sides by r here. So if you do that, you get your right side as r squared is equal to 40r sine of theta. And the reason why that helps you is because you can replace r squared with x squared plus y squared. And this r sine of theta you can replace with y. So thus you get rid of all polar things. So you'll have x squared plus y squared is equal to 40y. But you're going to want to change that. So you have x squared plus y squared minus 40y is going to be equal to 0. And you want to complete the square in this case. So to complete the square, you're going to have to half this value right here and square that. So that's going to be plus 400. But since we added 400 there, we're going to have to add 400 to the other side. So plus 400, and that's going to be equal to positive 400 here. Okay, and then you can write this as a perfect square. So you could say y minus 20 squared is equal to 400. And so you have x squared plus y minus 20 squared is equal to, shouldn't that be 20 squared? So there you go. So it's a circle equation with at the center at 0, 20, and the radius is 20. Okay. Okay. Trying to decide if I want to do this next part in one video or in another video, or if this what we've done so far. Yeah. I think I'm gonna do that in just a quick other video. I don't like making the videos too long because they take very long to upload. So for the last remaining problems, I'll do that in another video.